Well, hey everybody, welcome back to Old School Math. Today I'm going to be talking to you about solving systems of inequalities, and we're going to look at that by doing graphs. The two big I can statements we have for this are I can graph an inequality, and I can solve a system of inequalities by graphing. We'll need to be able to graph an inequality before we can hop into solving that. So a couple notes for you here. Graphing an inequality is very similar to graphing a line. In fact, if you can graph a line in the form y equals mx plus b, you can graph an inequality. The only difference is instead of an equal sign, you're going to have a greater, a less than, or greater than or equal to sign, or a less than or equal to sign. And depending on that sign, it's going to change how the line actually looks. If the inequality is a greater than or a less than inequality, then the line needs to be dotted, or we could say dashed if you want to. And if it's greater than or equal to, or less than or equal to, then the line should be solid. Now this actually kind of makes sense if you think about it. If we've got an or equal to, then it's going to look very similar to y is equal to mx plus b. So if you ever see that equal sign underneath the inequality, then that means you've got a solid line. That means those points get included in the graph. Whereas on our dotted line, it's all the points right up to that dotted line, but not the dotted line. Again here, let's reemphasize the points on the dotted lines are not points that work for the inequality, and they're not part of our solution for our system of inequalities. To determine where to shade, you're going to need to compare the inequality with y. If the equation is the form y is greater than, or y is greater than or equal to, then we're going to shade above the line. Let's pause right here for a second. We're shading above because that is where y is going to be greater. It's going to go up. It's going to go into more and more positive values. If the equation is the form y is less than or y is less than or equal to, then we're going to shade below the line. So our line represents where the y value lies, right? So we're going to shade all the values that are lower than that. The solution to a system of inequalities is just everywhere the line shading regions overlap. We're going to look at 3 examples together. Be sure to use that pause button if you need to and take things a little bit slower. Otherwise, let's work these together. And if you've got your note-taking guide, these are the 3 examples on your note-taking guide. Our first example has the 2 inequalities, y is greater than 2x plus 1 and y is less than x plus 2. Let's start with our first inequality and just take a look at it before we graph it. First off, this tells us a lot right here. It tells us if the line needs to be dotted or solid, and since it's just a greater than, we know that it's got to be dotted, and we know that since it's greater than, we have to shade above the line that we graph. So let's start here. 2x plus 1, our y-intercepts at 1 will go up 2 over 1, up 2 over 1, up 2 over 1, down 2, left 1, down 2, left 1, and we can draw our dotted line in here. Great. That drifted a little bit. Good. Now the next thing we need to do is shade everywhere that is above that line. So if my y value here is 1, we're going to shade up to the 2, and the 3, and the 4, and it's really just this whole region up here. Okay. Now the second one we're going to do in a different color. So if you've got a different colored pen or different colored pencils, this might be helpful in seeing where our shaded lines overlap. So y is less than x plus 2. So this less than sign right here tells us that we need to shade below, and it tells us that the line needs to be dotted. So x plus 2 would look something like this. Y-intercept is at 2, up 1 over 1 for a slope of 1, up 1 over 1, and so on. Let's continue this down here, little ways. We said we needed a dotted line. Okay. And again, on this one, we want to shade below that line. So here we're shading all this space that is below this line. Now if we take a look, really it's just this space in this little wedge here where the blue and the green overlap. That overlapping region is the solution to my system. Even though we shaded over here with the blue, below that line, y equals x plus 2, and even though we shaded above that line, y is less than 2x plus 1, that's the only region that actually works. What this means is I could pick any point in here that is not on these lines, mind you. I could put any point in here, I could substitute for x and y in both inequalities, and that point would satisfy both inequalities. Our second example looks pretty similar, but in this first equation here, our first inequality, we have a y is greater than or equal to. That tells us two things. We need to shade above the line, and it needs to be a solid line because we have an equal sign there. Negative x plus 3 plus 1, 2, 3 is our y-intercept, and a negative x is going to go down 1 to the right 1, and we'll do this a ways, and vice versa up here. Looks good. Let's make a solid line through it this time, since it's a greater than or equal to, and we're going to take all these points and we're going to shade above that line. Looks good. The second one, y is less than x minus 1. So since it's less than, we know we need to shade below the line and it needs to be dotted. X minus 1, our y-intercept is at minus 1, and our slope is 1. Let's go ahead and find some points on that line, and let's connect those with a dotted line there. Since it's a less than, we said we want to shade below it. This one might be a little bit easier to see where the two areas overlap. It's going to be anywhere in this wedge. This part is not a solution to our system, though it is a solution to the inequality y is less than x minus 1. And this is not part of our solution either. Now, if you don't want to go back and erase yours because you're using colored pencils or something like that, just make a note. Say, hey, it's where the two overlap, right? Or just make that extra dark. For our third inequality, we're going to look at y is less than 4 and y is less than 1/2 x plus 2. Don't let this worry you. Just because there's no slope, it just means your line is flat wherever y is 4. Let's take a look here. Here's where y is 4. So we're going to draw a dotted line since it's a y is less than inequality. And we're going to shade everywhere below this line. Everywhere on that graph. It's a lot of shading. So mine's going to look incomplete. The next one we want to do is y is less than 1/2 x plus 2. Now, notice we're still doing an inequality that is a less than inequality. We've got a slope of half, and we've got a y-intercept at 2. So let's go ahead and put that on the graph. So that slope of half means we go up 1 and over 2, up 1 and over 2. Continue that pattern back this way. And since we've got a lot of stuff going on down here, I'm going to actually kind of extend this to the edge of the graph. Likewise up here. Sounds good? It's a less than inequality, so we're going to make this a dotted line. Yep. And we're going to shade below this line as well, since it's less than. All right, looks good. So the only question that I have left is what's actually the solution to our system of inequalities here? Well, this right here, I don't see any blue. It's just the less than, y is less than 4. And in this section, I don't see any green. So here is our intersecting region. Hey, I want to thank you all for watching this video, taking the time to check out Solving System of Inequalities by Graphing. If you still have a question, drop it in the comments below and I'll answer that as soon as I can get to it. Otherwise, thanks for watching. Be sure to subscribe.